Good afternoon or morning or whenever you're watching this video. I'm actually currently making this video at 4:28 on Wednesday here. And I'm a little tired and I want to go home and I feel like I'm dead. And so here are my dead glasses. Feel free to steal this idea and convince your friends that you're really witty whenever you're not and you just stole this from your really lame forensic science teacher. See, I'm dead. X's. Okay, cartoons. Okay, so here's a real quick thing with test review. I'm sorry I did not get around to making a lovely, fun, interactive game, but time kind of caught up on me on this. So let's talk about what is actually going to be on the test. First thing, lab safety. Look at the lab safety rules. Know the basic stuff. I'm gonna ask a few questions about. You need to know what happens if there's a spill, if there's an accident. You need to know what happens. You need to know some of the lab safety equipment. Basically, any rule that's on our list is free game, but there's not going to be a whole lot of questions on it because I assume that you know it. The MSDS, the material safety data sheets, know how to read these. I would say Google one and look at it. You know, take one like I think we use silver nitrate in class. Google silver nitrate MSDS. And look over it. Some of the things you need to know is where to find the name and manufacturer, where to find the properties, reactivity, first aid. What do you do if it is breathed in? What do you do if you eat it? What if you do if it gets on your skin? And also personal protection. How do you keep yourself safe from it? Scientific method, which is so awesome, even though we won't be using it as much this year because forensic science bends the rules of scientific method a little bit. You need to know what science is and what is not. This was covered in the video lecture, the 1.2 video lecture. You need to know about a hypothesis. What makes for a good hypothesis? Is it testable? Is it based on good observations and research? You need to know what a theory is. Okay, that a theory is your inference based on observable phenomena. Okay, and so know what a theory is. Know what a law is. Know the differences between the two. Okay, theories don't ultimately just become laws. Generally, theories support a law. A law is something that we think happens all the time. Okay, observable phenomenon that happens all the time. So we have a law that describes what is going to happen, and then a theory backs up what we see. Okay, you need to know independent, dependent variables. We'll talk more about that in a second. Steps to the scientific method, you need to know these in their general order. You ask the question, then you research it, then you construct your hypothesis, form the experiment, analyze the results, draw your conclusion, communicate the results, and rinse and repeat, okay, if you need to redo it. Experimental design. I'm not going to have you actually have to design an experiment, but what I will have you do is I will give you the premise for an experiment, and then you are going to identify the independent, dependent variable, the constant, control, and experimental group. Okay, so remember, your independent variable is what you change in the experiment. Okay, and then your dependent variable is what changes because of that. Remember, in like the dog experiment, the independent variable is the types of food. That's what you changed between each group. What was dependent on that then was the health of the dog. Okay, your constant is what you're keeping. What you're keeping constant throughout the experiment. Like in the dog one, that would be the size of the pens that they're in, the time of the day that they eat the food, how much food they eat, who feeds them. That would be the things you're keeping constant. Also, those are called control variables from time to time as well. I say that because the control group is your group that you leave alone, that you do not give them any type of weird independent variable to throw things off. That would be you would have a group of dogs that would just eat regular food. Okay, just a standard generic food. That would be your control group, excuse me. And then your experimental group are the ones that you're changing that. Think of we talked about the rat experiment. The control group was the group that was getting the sugar shots because that doesn't do anything, and then the group that was the experimental group were getting the reduction medicine. Observation versus inference. There'll be a few questions, 5 or 6 on the test, where I will give you an observation. I'll give you basically a written out statement, and you will tell me whether or not that is a good observation or whether or not that is a good inference or a bad inference. Like here, this bologna sandwich has an interesting taste. That's an observation. An inference is, someone poisoned me. I think it's Al-Qaeda. Okay? You just need to get out more. Okay? Like an observation is, Mr. Smith has a beard. Okay? And a nice one at that. The inference would be, perhaps in a previous job, Mr. Smith was a beard model. Could be, but you don't have facts to support that. And I'll never let you know for sure. And then that's pretty much the test. Make sure you study for it and you come in ready to go. For fun, I just thought I'd throw in some pictures of my kids. This is my oldest son, Owen Ray. Yeah, no, this has nothing to do with the test, so this isn't like a bonus question, although it might be. This is my oldest son, Owen Ray. He's 4. He's awesome. This is my son, Chandler, cheesing it up with a little drool action going. And he is 2, and here's my little baby, Ellie. Her eyes look gigantic in this picture. So pretty much that was just for fun, so y'all can know me a little bit better. Have an excellent evening. Study well. Go back through and rewatch the other lectures and videos if you need to. Look at your notes. Have a lovely evening.